Today, let's dive right into the fascinating world of artificial neural networks and the groundbreaking work that earned John Hopfield and Geoffrey Hinton the 2024 Nobel Prize in Physics. The story begins in the 1980s when these two brilliant scientists made fundamental discoveries and laid the foundation for modern machine learning. But what exactly did they do? Let's break it down. First, let's talk about Hopfield's contribution. In 1982, Hopfield introduced what we now call as Hopfield network. Imagine a grid of light bulbs, each connected to every other bulb. These bulbs can be on or off, representing binary information. Now here is the cool part. This network can learn to recognize patterns. How does it work? Well, when you show the network a pattern, let's say the letter J, it adjusts the connections between the bulbs. Later, if you show it in a partial or noisy version of J, the network can reconstruct the full correct pattern. It's like your brain recognizing a friend's face even if they are wearing sunglasses or have a new haircut. But Hopfield didn't stop there. He realized this model was similar to how magnets work in materials, a concept from physics called spin glass theory. This connection between physics and information processing was revolutionary. It showed how collective behavior in a complex system could lead to computational abilities. Now let's shift gaze to Hinton's work. In 1985, Hinton and his colleagues introduced the Boltzman machine. This was an extension of Hopfield's ideas but with a little twist. The Boltzman machine added randomness and hidden nodes to the network. Think of it like this. Instead of just having visible light bulbs, now some bulbs are hidden behind the curtains. These hidden bulbs allow the network to capture more complex patterns and relationships in data. The Boltzmann machine could learn to generate new patterns similar to what it was trained on, a bit like an artist learning to paint in a particular style and then creating new, original paintings in that style. However, the Boltzmann's machine had a problem. It was slow to train. This is where Hinton's next breakthrough came in. He developed a simplified version called the restricted Boltzmann machine and created a faster training method for it. But perhaps Hinton's most significant contribution came in 2000s. He pioneered methods to train deep neural networks, that is, networks with many layers of nodes between the input and the output. This was a game changer. You see, for years, researchers thought training deep networks was too difficult. The signals would get weaker as they passed through many layers, making learning ineffective. Hinton found a clever way around this. He used RBMs to pre-train each layer of the network one at a time, like laying a foundation before building each floor of a skyscraper. This pre-training gave the network a good starting point, making it possible to fine-tune the entire deep network effectively. This breakthrough was a crucial step towards the deep learning revolution we are experiencing today. It's what enables AI to perform complex tasks like image and speech recognition, language translation, and even beating the world champions at any game. Now you might be wondering, why is this physics? Well, both Hopfield and Hinton drew inspirations from concepts in physics to develop their ideas. Hopfield's network borrowed ideas from the physics of magnetic materials. Hinton's Boltzmann machine was named after Ludwig Boltzmann, a physicist who made fundamental contribution to statistical mechanics. Moreover, these neural network models exhibit emergent behavior, where simple interactions between many parts lead to complex overall behavior. This is a key concept in physics, seen in phenomena from phase transitions in materials to the formation of galaxies. The impact of the network extends far beyond just a computer science. Today, artificial neural networks are used in virtually every field of science. In particle physics, help analyze the vast amounts of data from particle accelerators, playing a crucial role in discoveries like Higgs boson. In astrophysics, they have helped creating images of black holes and detect exoplanets. In climate science, neural networks are improving our ability to model and predict complex systems. In material science, they are accelerating the discovery of new materials like desired properties. And in biology, deep learning models like AlphaFold are revolutionizing our ability to predict the protein structures, a crucial step in understanding diseases and developing new drugs. But it's not just in science. The technologies developed from Hopfield and Hinton's work are well around us in our daily lives. Every time you use your smartphone to recognize your face, translate a foreign language, and get a recommendation of a movie to watch, you are benefiting from their groundbreaking research. In essence, Hopfield and Hinton's work bridged the gap between physics and information processing, leading a powerful new tools for understanding and manipulating the complex systems. They showed how principles from physics could be applied to create systems that can learn and adapt much like our own brains. Their contributions have opened up new frontiers in artificial intelligence and machine learning, revolutionizing how we process and understand information as well. From scientific discoveries to everyday technologies, the impact of the work is profound and far-reaching. As we look to the future, the full potential of these technologies is still unfolding. What new discoveries will they enable? How will they continue to transform our world? These are exciting questions that researchers are actively exploring, building on foundational work of Hinton and Hopfield. The 2024 Nobel Prize in Physics recognizes not just a scientific achievement, but the birth of a new way of thinking about information processing, one that has already transformed our world and promises to continue driving innovation for years to come. So that's all for today, folks. And if you like this video, don't forget to subscribe to encourage me to do more such content.